So, but you know that this one you have to borrow the 4-bit, right? And this one is a classes network /24. It is original network. Right? That is original network here. And of course, you see when you have the /24, sorry, when you have the /24, when you convert it to decimal, you have the 24-bit of number 1 and 8-bit number 0 here, right? That's why the subnet mask original one here, 255.255.255.0 here. Agree or not? Agree or not? That's the original one. I said
yeah,
that.
that is. I get it.
Yes.
Now, you borrow 4 bits. Huh? You borrow 4 bits here. So now it's not /24 anymore. You bring 4 bits from the hot portion, you bring it to the network portion. So now what is a / now? What is a / now?
28.
Yeah, 28, right? You see, you have the total, you have the 32 bits, right? You have the 2 portion, you have network portion and the whole portion here. Now for the network portion, you original one here, you have 24 bits. Right? Original one, you have the 8-bit here in the hot portion. Right? Now you borrow 4 bits. Right? So see, you borrow 4 bits, you bring it here. So now it's a /28. Right? So see, it's very clear with this one, right? So now we come back with the question here. How many subnet? 9 here, right? You need a 9 here. You need a 4-bit here. What will be the new subnet mask if you have /28?
Would it be 255, 255, 255, 240?
Yes. And the reason that you have the 240 because you see, you have the /28, right? 28 here. Now you break it down. You have 8-bit number 1, right? You have 16, you have 24. Now you have 25, 26, 27, 28, and you have 40 here. All right? Now you see, this one 255, right? 8-bit number 1, 255 here. 255 here. And 255 here. And this one is not converted 128 here. 64 here. 32 here. 60 here. You add them up together, you have the 240. Or you can use a calculator. You see, when you use a calculator here, you use a calculator here. No, not this one. Where? So you see, when we use a calculator, we go to the programmer, we put here to work with the binary. So we have 1, 1, 1, 1, 0, 0, 0, 0. You see, you have 240 here, right? You have 240 here. So that answers the question here. The new subnet mark it is a 255, 255, 255, 240, right? Okay. Now, what is the magic number? What is the magic number?
It's 16.
The magic number is the value of number 1. The magic number is the value of the last number 1 in the subnet mark, right? The magic number.
So it's 28 then?
No. Let me mention again. The magic number is the value of the last number 1 in the subnet mark.
Okay, so it's 16.
Right? So that is a 16 here. See, that is the last number 1 here, right? That one here is the last number 1 here. It's 16 here, right? Okay, so now 16, right? So now the 16, the magic number here is 16. And I mentioned it clearly on the class that when you break it down in the subnet mask, right? The network address of every subnet mask here always increased by the step of the magic number, right? So now you see, let me come back in here. Let me share another one here. Yeah. Now see, at the big let me make it very simple here, right? At the beginning, you have the network of the /24 here, and the IP address 192 here, 168.43.0. That means you have everything from 192.168.43.0, right? And it come all over to the 192.168.43.255 here. That is the original network. Right? That is the original network, and it's a huge network here. And of course, 0 here, and 0 here is the network address. and the 255 here is the broadcast address. Now, you know that you borrow 4 bits, you break it down into magic number of the 16. Right? So see, the network address here always increased by the step of 16. So the first one here, 0 for the first network. Right? Now you come with 16 here for the second one. Right? Now you have the 32 here for the third one, and so on. Right? Just so on, just on. You have 48, and always increase by the step of the magic number here. Right? So see, you have 0 here to the 15. It is the first network. Right? 15 only. 16 here to the 31. It is the second network. And of course, 0 here, network address. 15 here, broadcast address. All right, so everything from 1 to 14, it is a host address. All right, so see, when you break it down on this one, they are not overlap. Remember that when you break down the network, you have to keep in mind that they never ever overlap it. They must be separate, right? And the reason that you can separate because now you see at the beginning it's a slot 24. Right? Right now we have the slot 28 here. So 28, that means you only have the 4 bits. You only have a 4 bit in the whole portion. Right? So see, in the 4 bit in the whole portion here, the second formula, right? You have 2 raised to the power of h here, h is 4 bit, right? So in total, you have for here, you have the 16 bit, but you have to minus 2, right? 1 for the broadcast and 1 for the networking. And so see, you have the slot 28, so that's why you break it down into the multiple subnet here, and they are not overlap. But I see some of you make mistake here. Even that you break it down into the 192.168.64, sorry, 63.0 and 192.168.43.16. But you do not change the subnet mask. When you did not change the subnet mask, you got the overlap. It was overlapping. The thing is that side, if you put it 255 here, I put it 255 here. It's huge range here. So we see they are overlap. They actually both of them here belong to the same network, not the two networks. So only when you convert it to the slot for 28 here and 28 here, they are separate. Got it or not?
Yes.
What is the one who tell you how many host address? What is the range of the network here? So whenever you borrow something, you change the subnet mask. Now see, at the beginning here, slot 24 is 255, not 255, not 255, not 0. That means the range of this one is everything from 0 to the 255. But when you change to the slot 18, the range is everything over only for the 16, right? So it's only from the 0 to 15 and 16 to 31 and so on only. So that's why some of you when you work as an assignment, you send me the email why I got the notification error that you have the overlap or you cannot configure it because you did not change the subnet mask here. So when you did not change the subnet mask, all of them again on the same network, they overlap together. Okay. Any other question for this one?
Can we work on some of the table? I'm kind of lost on the table.
What table?
The
One, right? This one?
no, the a little bit more down.
Okay.
It's
now when we work with this one, right? You know that's the network address over increased by the magic
I'm
number.
stuck on 814, table 814.
Okay,
That's
so,
what I'm struggling with.
Okay, I'm coming with this one. 32 and 48 and so on, right? So
Yeah.
see, now the network ID, right? The broadcast ID is one that come right before this one, right? That's why you have 15 here. And a range of the host, you have 1 to the 14 here, and do it so on. Huh? It's very straightforward here. So I don't know why. If you follow my lecture, I record it, and in the class also, it's very straightforward here. Okay, now come back to this one. What is it? Let's see. What is subnet again? How many borrow and change it? What was the process for knowing what change? Yeah. What change does that mean? How many bits you borrow? That's all. 24, 28. Right? So you know that you have to borrow 4 bits. Right? You know that you have to borrow 4 bits. That means at the beginning here, you have slot 4. Sorry, slot 4. Now you change it to the slot 28. That's all. Right? Of course. And you know that when you change to slot 28, that means you have 28 bit number 1. Right? And 4 bit number 0. So you see, 24 bit number 1. Sorry, 28 here. 8 bit number 1, 16 bit number 1, 24 bit number 1, right? 25, 26, 27, 28. And of course, when you convert it, 255 here, 255 here, 255 here, 240 here. Huh? Clear or not? Hello?
Yeah.
Okay. Now, see. Now, one thing about this one here. You see, if you know that, when you break it down the slot 38, right? That means you support for the network of 4 bits in the hot portion, right? And the 4 bit in hot portion here, you have 2 raised to the power of 4, you minus 2. That is the second formula, right? So that means you are able to support the 14 port address here. Now, if you look on the connection here, they call it the point-to-point connection. Point-to-point connection. Point-to-point connection. Why? What is a point-to-point? Point-to-point, that means this is network, you only need 2 addresses. Right? So for this one here, you only need 1 for this one, and you only need 1 for this one. That's a point-to-point connection. You see, you only need 2 addresses only, right? But now you have to use the 14 here. That means each of them you wasting the 12. It's not good at all. Right? So that's why I see for this one you can break furthermore. You can break it down furthermore. All right. So as I explained it on the class, the same, right? You have the pi here. You can break it down 1/2 for me. All right. Break it down furthermore. Break it down furthermore. Right? In order to save the IP address here. You see, if you do not break it, you're wasting each of the network here 12 address. Even that you don't use it, you cannot use it any other one here because each network must be separate and not overlapping. Right? So now for this one, you see, you have the point-to-point connection here. Point-to-point connection. You only need 2 address. Now, see, what do we think? What do you think? If you have slot of 28 here, right? Right now we have a 28 here, right? So what happened here? What happened if you borrow 1 bit? What happened if you borrow 1 bit? How many subnet you can have? 8. No, I'm sorry. What happened if you borrow only 1 bit from the whole person? Right now we have a slot 28 here, right? Now, you see, how many point-to-point connection you need? If you look at the topology here, 3, right? 3. Now, you see, you need the 3 of them. So now we see that you need to break it down further. Sorry, you need to break it down furthermore. You need to break it down furthermore in order to support for the 3 subnet here. So I think how many bits you have to borrow? If you want, yeah, 2, right? 1 is not enough. 1 is only 2 raised to the power of 1. You only able to support for the 2 subnet only, right? So this one here, you have to borrow 2 bits. So we have a 4 subnet. Of course, when it's a 4 subnet, you are able to support for this one, this one, and this one. All right? So now see, they reserve the first one, you break it furthermore, right? See, you have the first one here, it is slot 28, and you have 180, sorry. You have 192, 168.43.0. That is the first one, right? And everything from 0 to the 15 here, and you have slot 28. Now you know that you have to borrow 2 bits. All right? You have to borrow 2 bits. Now see, you have slot 28 here. If you borrow 2 bits, you have the slot 30 here. Agree or not? Okay. Now you have the slot 30. What is the subnet marked for the slot 30?
Is that 255, 255, 255, 252?
Yes. Right? Is that converted? You can use the calculator again. You put it here. 30, that means you have the 6 bit here, number 1. And you have 2 bit number 0. And of course, when you convert it, you have 252 here. Right? So you have 255, 255, 255, 255, and 252. For each of them, right? You must be the 252 here, and 252 here, and 252 here. 2. Okay. And now see, if you select 30 here, how many bits in the whole portion you have? How many bits in the whole portion you have?
2.
Only, right? In total here, you have the 32 bits. Now we will have the 30 bits in the network portion. I select 30. So we have only 2 bits here in the whole portion. So if you have a 2 bits here, if you have a 2 bits here in the whole portion, how many whole address you have?
You have 2 usable ones.
Yeah, so you have a 2 raised to the power of 2 minus 2, right? 2 raised to the power of 2, 4 minus 2, you have 2 usable. Right? So see, it matches perfectly with the point-to-point connection. You only need 2 only, right? So see, when you break it down here, now again, you know that this one break it down in the slash 30, right? And okay, you have to find out what is the magic number for the slash 30. What is the magic number for the slash 30? 1, 2, 3, 4, 5, 6. You see, slash 30, that means you have 8 bit here, 24, right? 25, 26, 27, 28, 29, 30, and the magic number here is slash number 1. What is it?
Zach said 4.
4, right? See, this one here, 1, this one here, 2, this one here, 4, right? Okay, so the magic here, number 4. So see, that's basically, again, it breaks down into the subsequent network here. The first one is 192.168.43.0, right? Add it with the magic number. The second one is 192.168.43.4, right? Add it to the magic number. You have 192.168.43.8, right? And the next one is 192.168.43.12, right? You don't need to use this one because you only need the 3 network here. You see, this one here, 0 here, actually everything from 0 to 3 only, right? 0 is the broadcast address. 0 is a network address. 3 here is the broadcast address. So actually you only able to use 1 and 2 for this one, right? And again, this one also, you only able to do 5 and 6 for this one, and this one you only able to 5, 9, and 10 for this one. That's all. When you done everything. Any question?
No, it makes a lot more sense now.
So see, it actually gave you here already. 0, 1, 2, 3. And again, you have 4, 5, 6, 7, and again.
Okay, here's the part I'm struggling with.
Yeah, and one more thing about this one here. I see that some of you make mistake here. Remember that this one, right? This one is a network when you connect it to this one here, slash 28. This one here, slash 28. But this one here, slash 30, not 28 anymore. That's why when you convert it subnet mask, it's not the same anymore. This one here, 240. This one here, 240. But this one here, 252. I don't know why some of you keep the same 240. Never ever work. This one.
What are the dashes for the rest of them now? I don't understand. I'm kind of confused.
So you have to apply the process here. I cannot do it for you. If you understand the logic, you have to figure it out here. If you understand the logic, you have to figure it out here. Okay. Any other question for the homework or assignment? Let me know. That's why I strongly recommend you again that whenever you have the homework, you have to do it from the beginning. Do not wait until the last day. And you see that I see that some of you keep sending the email. Why is that? Why is that? For yesterday. I still have time to help you, but it is your problem here. If you have the short time, it's very hard for you to work as a homework. Yeah. And again, if you look on the process, the whole process I explained it to you. Actually, I already cover everything on the class. If you look on this one, I cover everything on the class on my lecture. In sum up, right, you only know what is the subnet mask, how many bits you have to borrow, what is the magic number. That's all.
Right.
Okay. So, any other question? Hmm? And I just see that some of you, and I can see that some of you when you work with this one here. Oh, let me see. So think of that this one here. You can ping from 0 to 1, you are able to ping it. You can ping from 0 to 3, sorry, to 2 here, you are able to ping it. But you are not able to ping to the PC 3, the 4, or 5, or 6 from the PC 0 here. From PC 0, you can ping to the PC 1 and PC 2. It's okay. But you are not able to ping the PC 3, PC 4, PC 5, and PC 6. Why? Why you are not able to ping it?
Why did you use difference of that? Why did
It's because the router serves as a sort of gate to block off broadcasts.
No, it's not broadcast. If you ping from one computer to another computer, it is a unicast, not broadcast. Not broadcast.
Oh, I was thinking of something different. Sorry.
What is the difference of that? And if you set a different subnet, this one also, from this one here, right? Now see. From the PC on this network and the PC on this network, you see, they are not the same subnet here. But you are still able to ping it. Why? I mentioned it on the class already.
Oh, is it because they're both, the two subnets on a router are both on the same default VLAN of 1?
No, each of the subnet is each of the subnet is a separate network. And we see the computer here, the default gateway is interface here, right? And the computer here, the default gateway is here, not on the same network and not the same default gateway. The question here is why? Why you are able to ping from PC here to PC here or PC2, but not 3, not 4, not 5, not 6? I mentioned it on the last class. If you remember the process of the routing table. Okay? What is
because the communication can't go through the router, it can only go through the switches.
No, it's not that one. No.
It needs to be on the same subnet.
No, it's not the same subnet. You see, this one here is one subnet, and this one here is another subnet. So even that PC0 and PC2 and PC1 here, they are not on the same subnet, but you still able to ping it. It's not a problem.
Would it be because the router 0 doesn't have those router 1 and 2's the things on its routing table yet, the addresses?
It kind of. Yeah. Now, come back to the definition of the last slide. Routing table. What do we have in the routing table? What do you think? What do you have in the routing table? Now, come back. I want to review again about the last class here. The routing table. I mentioned about the routing table. What do you have in the routing table? What do you have in the routing table?
Like the MAC addresses.
No, not MAC address. Remember that the router is a layer 3. It works with the IP address, not MAC address. The MAC
The
address,
destination address.
MAC address here is when you work with the switch, right? The MAC address, and remember that in the switch you have the MAC address table here. And of course, in the MAC address table, you have the MAC address and the port number. Remember that the port number only, because the switch have no idea what is the IP address. Right? Now we come with the routing table. What do you have in the routing table?
So the routing table would be the IP addresses, correct?
Yes. You have the IP address and what?
And port numbers?
Port?
It can be the port number, yeah. It can be the port number, or it can be the IP address of the destination here, right? So think about this one here. It always has a matching between the IP address and the port number or the outgoing here, right? Or the next IP address. I can tell it later here. So now thing is this one here. From the router 0 point of view here. From the router 0 point of view. You have the definition about the directly connected network, and the remote network. Do you remember it or not? Directly connected network and the remote network. The directly connected network that you can think about your body here. You have everything directly connected to you. I see from the router 0 here, from the router 0, right? You see, you have the 2 networks directly connected to you, and even this one also. For the router 0 here, you have a 3 directly connected network. That means you know for sure what you have, right? So see, when you send from the PC 0 here, when you want to ping the PC 2, you send it to the router 0 here, and you know the router 0 know what he had, right? He had, and he's not forwarded to this one here. But what happened here? When you ping to the PC 3 here, right? When you send to router 0, you have no idea what it is. You have no idea, because this one is not directly connected to him. Right? Now let me show you about. I go back to the routing to the packet chaser. I show you that. So see, and this one also. This one has something wrong with the configuration. That's why you don't have L here. That's why you don't have L here. There's something wrong with this one. With the configuration. Now see, for this one, right? If you look at, sorry. Where am I? Now, if you look at this one, right? The router 0 here. You have the 3 network, 3 directly connected network, right? You see for this one here. 3. You have 1, right? You have 1. You have 2, and you have 3. That's why it automatically shows up on the routing table. You don't have to do anything. Right? Whenever you configure the IP address, whenever you configure the subnet mask, and you activate the interface, it will show up on the routing table here. Right? So show up on the routing table, show up on the routing table here. That's why here, .0 is a network here, right? And have the .16 is this node here, and .32 here, right? So think about this one. You have the computer here, is a PC 0. Everything is this network in the 16 network here, right? And you want to ping to the computer here on the 32. So when we send to the router look it up on the routing table, and he knows that in order to deliver to this network here, he's forward it out to the port here. All right, makes sense, right? That means you can see the directly connected network is that one is directly connected to the router. And you don't have to do anything. You just configure the IP address, the subnet mask, and activate the port. It will automatically show up on the routing table. Huh? But you see, you don't have any information about the other network. This guy here, actually this guy here, it will be the 192.168.43.48 here. You add it up to magic number, right? And the next one will be the 64, and next one will be the 80. You don't see such information about the 48, 64, and 80 here. That's why you have no way to ping from this one to the PC3, 4, 5, and 6 here. Right? Basically, right now you cannot do it. That is the correct answer. And it answers for the question why you are not able to ping from the PC0 to the 3, 4, 5, 6 here. Right now we cannot do it. Now, that's why I want to for that reason, I want to review about the last class here. Okay, now let me review about the last class. The first definition about the routing table. Right? The routing table is only tell you that what is a network IP address definition, network IP address, and you can think about the finally it will tell you what is the port you have to forward it out, right? The port here, right? The port is forwarded out here, and in the case of the routing table, you know that you only have the IP address here, IP address and the port number, right? 0/2 or something, right? Only tell you. Now, for the routing table, you have the directly connected network. That means directly connected to you, and you have remote network also. You have the remote network also. So if you look on the topology here, every other network, right? So if you look from the router 0 point of view here, every network not directly connected to him, it is a remote network. You think this one is remote, this one remote, this one remote, this one remote, this one remote, and this one remote. All of them, right? Only have the 3 directly connected network here. Agree or not? Okay, so that's the definition, right? That is the definition about the remote net. Sorry, that is definition about the remote network and directly connected network here. So we know that the routing table you only have the mapping between the IP address and the interface. Is the interface here. Now, so in order to have the something show up in the routing table, the first thing here you see, you have the directly connected network, right? Directly connected. So in the case of directly connected network, normally you don't have to do anything, right? After you configure the IP address, subnet mask, activate it, always show up on the routing table. And we have the C here. C that means directly connected network in the routing table. So for the remote here, for the remote network that means not directly connected to you. Right? You have 2 ways to do that. The first one is the manual rerouting, and the second one is a dynamic routing. So for in the case of manual routing, you have to manually configure it, right? You have to tell how you forward it to the destination here. And in the case of dynamic routing, you exchange information together. You remember the definition I mentioned it on the last class, right? Okay, in the case of dynamic routing here, you advertise together, you exchange information together, right? You tell that I have this network, and this guy tell him I have this network, and after that I exchange information. I learn it from each other here in order to update in my routing table. Right? And I also mentioned that the manual routing is only work with a small network only. It only work with small network because anything change in the topology, they cannot adapt it. Now I think I have to go back to the slide here. Okay, so you have the 2 types. You have 2 ways to do that. The first one is static routing or manual, and the second one is a dynamic routing. So in the case of static routing, you have to manually configure, and it only works with a small network only. It only is a small network here because I think about this one here. Think about this one here, right? You have the sort here. And in the sort, you have to go to the default gateway. And in the default gateway, you might have the 2 way, right? You have the router 1, and you have router 2 here. And you go to the destination here. So it's a kind of manual routing here, right? So see, I configure it here. So whenever you go to destination, I forward it out of the port here. Right? That's the manual thing. I have to do it manually. I have to. But what happened here? When this link going down, you have no way to reroute it towards this one because it manually configured. And so if you want to reroute is this one, you have to come to the router. You have to manually config and tell that now if you want to go destination, you have to forward it on this one. That is a huge problem of the static routing or manual routing here. Right? It cannot adapt it.
That makes sense.
Yeah, it cannot adapt it, and it cannot learn it from the neighbor. You cannot learn it from any chain in the topology here. But
And in like a really big network where there's lots of PCs connected, and if any one thing changes, it would be really complicated to change if it was static, right?
So see, this example is only about the small network, right? But you think about, if you think about the huge network here, you have a huge network here. So see, if you want to manually configure it, you have to manually configure from this router, this router, this router, this router in order to go to that station. And
it's like possible, just not like realistic.
Yeah, you cannot do it. Actually, you cannot do it in the
okay, sorry.
Yeah, it's in the large network. You cannot do it.
Gotcha.
Yeah, in the kind of static routing, it only works in a small network. What is small network? You can think about the home network. So what is it? In the home network, you only have one way to go out. Right? You only have one way to go out. So instead of the static routing here, you can, instead of dynamic routing, you can configure it. It is a static routing here. You know for sure, I only have one way to go out. So whenever I go out, I just forward to this one here. I don't have any alternative route in the case of my home network here, right?
Okay, that makes sense.
Okay, and the dynamic routing is that you always exchange information together. You learn it from it together. You update together, right? So think about this one here. Oh, he tell him that, oh, this one link going down. He tell it to you, right? So now he understands that you have the better way to go to that station. You always learn from each other and update in the routing table here. Okay, so you have the manual routing, dynamic routing, and you have routing protocol also, right? You have the sum of routing protocol. I mentioned it on the class. I just go about again this class everything about definition of it. Right? You have something about RIP, you have OSPF, right? And you have the EIGRP. And in the routing protocol, again, they break it down into the interior, right? Interior, and the exterior. Interior, that means everything inside the network. They call it the autonomous system here. You can think about inside AT&T network or inside Smithfield network or Verizon network here. Right? And exterior, that means when you interconnect two networks together from the one AS to another one here. So think about when you connect from the AT&T to Verizon here. Right? Now, in the case of the routing protocol, again, they break it down in the distance vector and link state vector here protocol. What is the difference between the link state and distance here? I mentioned it on the class also already. What is the difference between the distance vector and the link state vector protocol? Any idea? Come on.
So the distance vector, it sends the routing table to like the devices that it's connected to, right?
Say again. What is the distance vector?
The distance vector protocols, it just like it sends the routing table to the other devices that it's connected to.
The distance vector, you can think about everything here work as a rumor here. It's a heard from the neighbor, but you have no idea of the overview of topology from the source to that direction. So why do you have the rumor here? So think about this one here. I have the sort, I send it to the router 1, and I send it to the router 2, I send it to the destination here. Right? So now think about the distance vector, right? You send the router 1 here, and the router 2 tell router 1 that I have the route to the destination here, so send it to me. Right? Send it to me here. So he have no idea about things like this one. You can have another one. Think about this one. You have no idea that I have the overview of topology network here about this in the vector here, right? So what happened here in one of the problem with the distance vector, it has a looping problem. I see this guy here tell router 1 knows that in order to send it to that direction, right? He sends the router 2. But if something going wrong with this one, router 2 again detect that the best part here is router 1. You see, it's a ping pong here forever. The reason that it's ping pong here forever because you have no idea what is the best way. Sorry, what is the topology to go to the destination here. Right? So if he knows that, if he know about topology, he know for sure he have no way to send it to the router 1. Agree or not? If you understand about it, yeah, you have the overview, you have the picture overview of the network here. You know for sure when it's router 2 here, he has the forward into the destination here. But if you don't have understand the logic of the topology, you just blindly send it back in the curve loop here. That's the problem about distance vector. Distance vector here, that means work with the rumor. It only heard from the neighbor only. But he have no idea what is the overview of the network here. What is the topology of the network here. And that's why also it works very, very slow. It works very, very slow in the slow conversion here. So if something going down, it takes a lot of time to adapt it to the new network here. And in the case of distance vector here, you maintain about the topology also. Right? Every router on the way from the source to destination here, he have the overview how they are interconnect together. Right? So think about this one. If this one link going down here, he have the overview, right? He instantly know that the next one here, you have to go to the router 2 here and send it to the destination here. Right? That's why you have to understand the difference between the distance vector and link state vector. And of course, everything has and pro and cons. This one very simple. This one very simple for computation. This one is more complex, and it consumes a lot of memory and processing time. Consume memory and processing resources. Of course, here you maintain everything about the routing table, about the topology table in the network. That's why it consumes a lot of memory. And also, everything in the network here, you have to do a lot of calculation again. You have to figure out what is the best way, what is the best alternative for here to reach that destination. That's why for this one, it consumes more memory and consume more processing here. This one very simple, but not very good. Yeah, efficient here. Okay, so now you know that the router, you have the two functions of router. The first one is interconnect the network together. The second one is only tell you which way is the best way to reach destination, right? So in order to tell which way is the best way to reach destination, you have to maintain about routing magic here. The routing magic, that means how much you have to pay in order to go from the source to destination. Think about this one here. He has a source here. And you go to the router 1, and you go to the router 2, and you go to that destination here. And or you can have another way. Router 2 here, sorry, router 1 here. You go to the router 3, and you go back to the router 2, and you go to that destination. So the router is always maintain the routing table. And in the routing table, you have IP address. And it's a port number here. The port number here. And in order to tell which way is the best way to reach a destination, it maintains about routing magic. Routing magic is that means you can understand that how much you have to pay in order to reach to destination. So it depends on the routing protocol. So if you're working with the RIP here, RIP is routing information protocol. It's a distance vector. It only works on hop count. The hop count here. Hop count. It only cares about the hop count. You see, if you go on this way, right? You have one count, you have two count. So this is the best way. if you work with RIP. Agree or not? So the routing magic here, you put it here, number 2. But if you work with this one here, number 1, number 2, number 3, this one, no, cannot be the best word here. Right? When you work with the distance vector and the routing magic here. So in the case of RIP, this one is the number 2, it's the best word. This one, number 3, is not the best word. That's why it's not updated in the routing table. Got it or not? Hello?
Got
Yeah.
it.
Yeah.
Okay. That is the case of routing magic. Routing magic here, it only tells you how much you have to pay in order to reach your destination. And of course, it depends on what type of routing protocol. For the RIP, it only cares about the hop count. It doesn't care about the bandwidth or anything here, right? So what happened here? If you have the 64 kilobits per second for this one, very, very, very slow, right? But what happened here? You have 10 gigabit per second, and you have 10 gigabit per second. But when the work is RIP, he just blindly tell you this one is the bad word because he only care about the hop count, right? But it depends. If you're working with OSPF here, OSPF, it work with the link state and you work with the bandwidth here. So for sure, when you work the OSPF, he understands that this one is the bad word and this one is the bad word. Even that you have to route longer way. But you see, it can drive way, way faster. That's why this one is the bad word here. So the routing magic here, it always understands that it's how much you have to pay in order to reach the destination. And the routing magic, it depends on the routing protocol. If work with RIP, it's a hop count blindly. But work with the OSPF, it's a bandwidth here. And of course, you have multiple routing protocol here. Make sense?
Yeah. So
Yeah.
what's the like default routing protocol for like when you get something and you haven't done your own setup on it yet?
Okay, so the default routing protocol is that in the case that if you don't have anything show up on the routing table, if you don't have to configure it in the routing table, it's just forward you on the same way. It's just forward you on the same way. Now, let me tell you here. Think about this one. How can I? Yeah, you have the source here, right? You have destination here. Sorry, you have the router here. And in that one, you have the router here. You have the 192.168.0 network, right? And you have 170.10.0.0 network here. So basically, right, when you want to reach your destination here, here, you must have something show up in the routing table. If you don't have anything show up on the routing table, the packet when you come to the router is the one who drop it. So see, in the case if you want to reach to the 192 here, 168.1.0, you know that you have to show up on the routing table and it's forward is 0/0 here. And for this one also, 170.10.0.0, you have 0/1 here. So now what happened here? What happened is I want to send it to the 150.10.0.0 if I want to forward it. So when it comes to router look it up in the routing table. He have no such information about this one. He will drop it. So now in that case, think about this one here. In that case, you have to go with the 160 also. He also will be dropped. In that case, normally they configure the default route. The default route, that means if you don't have anything show up here, you just forward it to the specific interface here. Now you can think about this one. You can think about this one here. Now let me give you another example here. So here it's our computer. You have the home network here. The home network here. You connect it to the switch and you connect it to the router. And from router here, you connect it to the internet. Now you see, what happened to this one here? Every computer on the home network, you go to the default gateway. And from the default gateway here, you know for sure, you only have one word. You will have only one way to go to the internet here. So in that case, also you can configure for the default routing. What is default routing? Default routing is that you don't care what the destination. So it can be 10.10 or can be 20.20 or 30.30. You don't care. You know for sure. Whenever you want to go out, you only have one way to go out. So we just forward it everyone. So that's why you configure it here 0.0.0.0 and you have 0.0.0.0 and you forward it out of G0 saturation. 0.0.0.0 and the subnet 0.0.0.0. That means you don't care about the IP address. You don't care about the subnet part. Whatever it is just forwarded out of G0 sub 0. And so in that case, they call the default routing. Default routing, that means you just forward it. You don't care about the definition.
That makes sense.
Okay.
Yeah, all right. Thank you for answering my question.
Okay. Now you have definition about the advertising ID, right? Advertising distance. Advertisement is yes. Advertisement. What is it? Advertisement distance here. Advertising distance. I forgot the advertising distance and the conversion time here. So basically, the ID is sorry. No, it's ID. Sorry, my mistake here. ID is administrative distance. Administrative distance. Okay, so the thing about this one here. If you think about the router here, right? Now come back to my example here. I have the source. I send it to router 1. I can go to send to router 2, right? And I send it to the destination here. Or I can send it to router 3 and I come back to the router 2 and send the destination 2. Now, it depends on the routing protocol, right? So what happened here? I have 64 kilobit here. Second here, I have the 10 gigabit per second here, and I have 10 gigabit per second here. Which one is the best way to reach from the source to destination? What do you think? Which one is the best way to reach from the source to destination here? If this one is 64 kilobit per second and this one is 10 here.
Of course, R1 to R2.
This one?
This is 42 gigabit.
This one?
Yes,
64 kilobit per second. Kilobit.
Gigabit, of course, then.
Okay. Now tell me, which way is the best way to reach from the source to destination? Can you tell me?
Is it the longer route?
Why?
Isn't the rate transfer faster on those ones, or am I misreading it?
This one 64 kilobit, this one 10 gigabit, right?
Yeah, so that should be faster, I think.
You cannot tell. The reason you cannot tell because it has to depend on the routing protocol. You see, I explained it to you. If you work poorly with the routing repair, it only care about the hop count, right? It only care about hop count. So if this one conflict with the repair, this one definitely is a bad one, right? He doesn't care about the bandwidth. He just care about the hop count. But the thing about this one here, if you don't conflict with the RIP, if you conflict with the OSPF here, right? OSPF care everything about the bandwidth. So this one is the bad one here, right? So very, very straightforward for this one. But what happened here? What happened if I configure both of the RIP and the OSPF here? All right. So in that case, the router have to take decision here. I have to make decision. What you have to work with the RIP or you have to work with OSPF. So in that case, you come with the idea of administrative distance. Each routing protocol, you have specific number of ID administrative distance here. And the lower one is the winner. Remember that the lower one is the winner. So think about this one here. I configure both of the RIP and OSPF here. And the RIP here, the number is 120. And the OSPF here, 110. This is the lower. It is a winner. So even that I configure both of the RIP and the OSPF, It's not work with it. It only works with OFP. So the idea here, you have to understand that it is just what it is of the root, and the lower number is the better, is the winner. Make sense?
Yes, that does now. Thank you.
Now we have some definition about the first hop redundancy protocol, and in that you have the hot standby redundancy protocol. You have the virtual routing redundancy protocol, and you have a gateway load balancing protocol. So that will give you the example here. I will just use the tutorial. Let me show you this. Okay. Too small. Now, if you understand about the idea of the redundancy, right? Redundancy, that means you have more than one way to go out in order to enhance, in order to solve problem of the single point of failure, right? So think about this one here. If you look on this one, I think about from the computer here, in order to go to the, I think about this, you can think about this one is a web server here. Web server here. So see from the PC here, right? I want to break it down into the redundancy. So if the link here going down, I still have the another way to go to the web server here. That is a kind of redundancy. So think about this one here. Now think about this one. Now think about this one. So basically, right? Normally I want to route it to the router one. As active here. Normally I want to do with the router one here. It's active here. And this one standby. So see, if I want to route it to the router one, right? I have to configure the default gateway of the PC. It is interface of the router here as a default gateway, right? So actually I have to configure it 192.168.1.1 here, right? Now what happened here? What happened here? If the router here is going down or the link here going down, even that, if you look on topology here, even that I have another redundant network as a route here, it cannot do it. It cannot route it. The thing is that it always sticks to the number one here. I see. When you forward it to the switch, forward it to the number one here, but now it's going down here. You have no way to work with this one. So that's in the case you have to working with the first hop redundancy protocol, or this way it is a host standby redundancy protocol here. So in the case of host standby redundancy protocol, they group the two routers together, and it works with the virtual VPA. That means virtual IP address, not the physical here. Right? So see, they configure it 192.168.1.100 here. Both of them work with the virtual IP address 192.168.1.100. Right? So in that case also, I configure it to 100 here. So what happened here? I send it to switch, right? The switch here. Switch forward it to the 192.168.1.100. So the 192.168.1.100 is a virtual IP address. It depends on topology. Right? So now, at the normal situation, you know that in order to matching to the 100 here, you have to forward it on this one. But if something going down, you understand it now. Right? Now we have to forward it on this one. That is the case of the host standby redundancy protocol, and it works with the virtual IP address. So you can see it here. You can see right now, right? What happened here? Let me simulate it here. So normally, right? So normally, if you do not work with the virtual IP address here, you have to manually configure with the physical here, right? So you see, now I configure it 192.168.1.1. I send the switch forward it to the router here, right? So route 0 here, and forward it to the 198.100.102 here. Sorry, not 198. Yeah, 198.102. What is it? Sorry, I have. Okay, so see, if I convert it dot 192.168.1.1, right? See, it forwarded to the router 0 here and forwarded to the destination here, right? But what happened here when I what happened here when I shut down the port here? I don't know. There's this one. Shut down the port. See, if I shut down the port here, see, if I shut down the port here, I cannot forward it to destination, even though that you see I have redundancy here, because it keeps sending to the 192.168.1.1 here. That's why I cannot do it. I cannot do it. So in that case, I have to manually, right? I have to manually to change it to number 2 here. So I have to manually to change it to number 2 for this one. So now you can do this. Yeah, so see, now we send it to the number 2 here, right? Yes, send it to number 2. No, not this one. Yeah, there is something wrong with that. Yeah. Yeah, I think something wrong with your composition. Yeah, I come back later. So anyway, that I want to review about the. Okay, so we have the definition about MPLS also. I remember about the MPLS. It is a layer 0.25 between the layer 2 and between the layer 3 here. So it's have the label. So instead of reading the entire the layer 3 message, breaking down with the IP address here, is have the label and it's reading. So we have too much time for the review and the already. Now I have to come back with the lecture here. Okay, so in the So in the module 10, you have the risk management here. Have some definition about the hacker. Right? The hacker, we have the white hat hacker. White hat hacker, actually, it's a good one here. Right? It's a good guy here. It can be the IT security expert, normally hired by the organization to, on the purpose of identify security vulnerability here. It's a good guy to show you what is your network vulnerability, and from that you can take the action to correct it. Right? And the second one is a black hat hacker here. That means this one is a bad guy. His purpose is that he can cause damage or steal data or compromise the privacy here, and illegally, right? He wants to take some money from it. And the third one is gray hacker. It is by a code of ethics or on the own. It's like the guy that want to show you, right? Want to tell you what is your problem. With your network here, it might be illegal activity because you got no permission to access in the network, but it's not only for the money. It's just want to tell you and want to say to you what is your problem. And have the definition about vulnerability. Vulnerability is a weakness of a system, a process, or architecture of the network. You can think about the vulnerability. You think that in the case of the home, right? You let the one window open. That is a vulnerability here. And when you have one window open, you have the high chance of being break in by the bad guy. And you have the definition about exploit here. Exploit is an act of taking advantage of the vulnerability. So you think about if it's a home, you keep the window open. It is a vulnerability. That's not a vulnerability, and you have a high chance of someone to take advantage to break in your house. And if you have to explore, it actually is the action only take advantage of the window is open and he break into the house here, right? And you have the 0-day exploit or 0-day attack. It's one of the take advantage of the software vulnerability here. So normally it is no one to detect the vulnerability before, and that is a guy who detect it and he will take the action to exploit the vulnerability here. I think we have the video here.
If you want to sell online, make sure you stand out. Go to Wix.
The term vulnerability and the term exploit are sometimes incorrectly used interchangeably. In this video, we'll look at the differences between these two terms. A vulnerability is a weakness. Sometimes this weakness is in an application, it might be in an operating system, or the weakness may be in the process that you follow that somehow allows someone to circumvent the security that you have in place. For example, a vulnerability in your home might be something like an open window. This doesn't automatically mean that someone will find their way into your home and take some of your belongings, but it is a method that somebody could take advantage of. What's interesting about these vulnerabilities is that some of them are never discovered on your systems. You could have your window open for years, but if nobody walks around to the back of your house, they may not even realize that a window is open. Sometimes we find these problems after years have gone by and that vulnerability has been on our system that entire time. There are many different categories of vulnerabilities. In your home, you might leave a door unlocked or you might leave a window open. On your computer, there might be data injection, such as a SQL injection, or you may find that your authentication process is broken and someone may be able to log in with a higher level account than what they normally would have access to. Perhaps your system unintentionally allows people to see sensitive data, or perhaps you've simply misconfigured the security on your system and people can gain access to areas where normally they would not have access. There are many different kinds of vulnerability categories. This is just a few of them. Normally, when you're providing a patch to one of these vulnerabilities, the organization that's providing the patch will tell you the type of vulnerability that this patch resolves. Vulnerabilities that may be on your system don't necessarily mean that someone has taken advantage of those vulnerabilities. When somebody does take advantage of an open window or an unlocked door, we say that they are exploiting that particular vulnerability. They're gaining control of a system, they're modifying the data that might be on your computer, or they're disabling or enabling certain services. There are many different ways to exploit a vulnerability. Someone may have to write a script or build an application to take advantage of a buffer overflow or a SQL injection. Or perhaps someone is simply accessing an area of the computer that was not properly secured. That may be very simple to exploit that kind of vulnerability. Our operating systems and the applications that we use on these operating systems are very complex. And undoubtedly, there are vulnerabilities that exist in those applications and in that operating system that we simply haven't found yet. Of course, there are researchers all over the world that are trying to find every possible vulnerability they can for every operating system and every application that may be out there. When someone does find that particular vulnerability, it's very common for that researcher to share that information with the developer of that application or the manufacturer of that operating system. There's usually a lot of development work that then takes place to be able to fix or resolve that particular vulnerability. At that point, the manufacturer will usually announce that the vulnerability exists, and they will provide a patch for that particular vulnerability. For example, Microsoft provides a set of patches once a month, and those patches are designed to address a number of different vulnerabilities that have been found. But of course, if you're a bad guy, you don't want to go through the process of having the manufacturer close those particular vulnerabilities. You want to be able to take advantage of those vulnerabilities yourself to gain access to data or systems. These so-called black hat researchers will identify these vulnerabilities that no one else has discovered yet, and they tend to collect them or trade them amongst themselves. They will then create an exploit that will take advantage of those vulnerabilities in order to gain data from those vulnerable systems. Sometimes a vulnerability will be discovered and then made public without the manufacturer having any opportunity to build a patch. We call these a zero-day vulnerability. And if somebody is taking advantage or exploiting that vulnerability, we refer to those as zero-day attacks. We usually pay close attention when these zero-day attacks are occurring because very often there is not a patch available to close the vulnerability. In those cases, you'll need to contact the manufacturer of the application or the operating system to see if there's a workaround or a patch that can be used against the zero-day attack. It's also a good idea to keep track of all of the different vulnerabilities that may be made public. A good index of these is at the Common Vulnerabilities and Exposure Database, or the CVE. You can find that list at cve.miter.org.
So I think this one is all about the definition. It should be better in what video. What else? Okay, so the people risk. The thing that you can think about the technology here, a lot of risks, but actually the more than half of the security breach are caused by the human error. It can be ignorance or omission. Right? Some of the most common thing is that social engineering strategy to gain the user password. You have some common type of the social engineering here. Phishing, you have the betting, you have the quid pro quo, you have the tailgate, you have the cookie backing, and we have a shoulder surfing here. So we have the definition about the phishing. Right? It can be the electronic communication that here come from it's pretend come from the legitimate person or organization and request access for the authentication information here. The bad thing is it is the malware infected site, such as free music download or such as USB flash drive. You have the quid pro quo. That means you have the free gift or the service offer in exchange for the private information or temporary access for the user computer here. Tailgating, you can just follow someone. You can follow the employer and you go on the follow the authorized employee into the restricted area. And you have the picky backing. The person using deception here to follow an authorized employee into the restricted area. And solo surfing, that you look over the shoulder of someone and see what he entered, what is his name, and what's the password. And the most important defense against the social engineering, definitely, is employee changing. Right? So you have to change the employee to see how can you react in the case of the social engineering. Right? So whenever you see the email, you have to look through the email and you can detect if something suspect with the email here, right? And never ever click on the direct link from the email. It's better that you see if you look it again and see what is the link you see. Right? And again, you have to understand that more than half of the security breach actually come from the human. Right? It's not from the technology here. That's why you only have to take the action here to change the employee in order to react to anything with the social engineering. Okay, so we have the sum of measure to reduce insider threat risk. The first one, perform background check. I see what the background check here. What is hit drawing here? Right? And enforce the principle of the least privilege here. Right? That one is also very important. That's one also very important here. You have to enforce the principle of the least privilege. That means you only give the minimal access to do the job. Never ever give more than that. Right? So think about if you are the engineer, it's the main purpose of you is about think about this one. You work in the network operating center here, right? And as that, of course, you may have multiple level of the engineer. You have the front office here, right? And you have the back office engineer, front office engineer, and you can have the support engineer. So in the case of front office, the purpose is only about the keep monitoring the alarm. Right? So in that case, you only give him the authorization with the show command away. Right? But in the case of back office engineer and the support, you have to dig down. You have to do the troubleshooting. Right? You have to investigate here. So you can give them about the authorization to do with the chain configuration here. Right? So that's why it only works with the principle of the least privilege here. So in the case of the front office, only give him the show command authorization only. He cannot do anything with the troubleshooting and cannot do anything with the chain configuration here. Right? And you can design check and surveillance on the employee behavior. Keep observing that, keep monitoring here. And you can deploy the data loss prevention solution to identify sensitive data. You can have the backup, you can have the encryption on that one here.
That makes sense.
Yes. Okay, so now we have the sum of the technology risk. The first one, the denial of the service loss. That is the most common. You can hurt it, right? So think about when you want to access to the website here, and you are not able to do it because of the denial of the service here. The denial of the service is an attack occur when the intruder here is a flood a broadcasting ping message to prevent legitimate user from the access the format or the network resources. Right? So think about we have the web server here. You have the web server here. And you are the legitimate user, right? And you want to access the web server. So think about this one. The web server here, the capacity of the web server here is at one time he only able to handle for 1,000 requests only, right? And 1,000 requests. So normally in the normal circumstance, you can access it normally, right? But if you have the bad guy here, he flood it, he send it to 1,000 or more than 10,000 requests at a time here. So see, very soon you run out of the resources, right? You cannot reply any legitimate request from the legitimate user anymore. And most of the time you are overload is the fake request from the bad guy. So that is the most common, right? So that's the most common attack you can see in the network here. It is about the denial of the service here. And you have some type of the denial of the service. The first one is distributed dots, DDoS here. It is through the several source called the zombie. That means he can control about the compromised network. Right? So from that, I think I have this one here. Yes. Here, the zombie here. You can think of it as a zombie. That means the bad guy, right? Is a bad guy here. He can take over the control of the compromised network here. They own the compromise. So they call it a zombie. Right? So now instead of sending from the one single computer to the web server, he can send it from the multiple compromised zombie computer here. He under the control of the zombie, and instead of the send from the single one, now he send it to from the multiple one here. So very soon you are overloaded here. You are not able to handle it here. Right? That is the first one. That is distributed here. The second one, the distributed reflection dot also. Reflection dot is a type of DDoS also. It's quite the same with the distributed dot here, and that is bounce up the unaffected computer and called reflector. Is a reflector. I'll show you what is a reflector later. And you can have amplify. You can have amplify distributed dots here, or you can have a permanent dots, and you can have a friendly dots attack also. So this one here, the dots. If you remember about the process of the TCP, right? About the process of the TCP. So if you remember about the transport layer, you have the two major protocols. It is a TCP and UDP. TCP is more reliable, and they call it a connection-oriented protocol because before you send out data from the source destination, you have the handshake, right? You have the handshake, and you have to process a three-way handshake. Two-way handshake. That means you see before I send, right? You have to send out the synced request here, and this one reply with the sync and acknowledgement here. And again, this one reply with the acknowledgement here. Right? That is a three-way handshake. So before any transaction, before any sending the data, you only have to handshake between the source and destination here before. Right? You have to send out the sync request here. So in the case here, that is a problem in the case of the synced flag here. You see, the bad guy here, he tried to send out multiple sync requests. And you see, if you work in the TCP and you have to follow the three-way handshake, every sync request here, you have to send it back with a sync and acknowledgement, right? So now he tried to send it out with many things here. He don't care. He doesn't care if you send the sync and ACK or not, right? So see, when you send it out the sync and ACK here, normally he have to reply you with acknowledgement, right? But now he doesn't send it back. So see, he sent it out for many things here, and he keep trying to send the sync and acknowledgement request, but he never ever send it back. So keep listening from him, right? Keep a lot of the resources from him. So very soon you overload here. Now think about if you have the legitimate user here, you want to access it, you have no way to do it anymore, right? Because he overloaded the sync request already. And that is the case of the DDoS here. DDoS, that means it's not only attack from the one single computer, but it distributed from the multiple compromised computer here. And you have this one is a reflection here, right? You see, you have a reflection here. Instead of directly attack to the web server, he sends the request from the many uninfected computer, and again this one reflects the request to the web server here, and this one you can think about this one amplify. So we see the attack here is very small here, but he can amplify it into the big attack from the think about this one. You have to open the NETI resolver here. what is it? Okay, so that is a first of the technology that the dot side. So the dot, you can break it down into multiple type dot. You have distributed dots, you have the reflection dot, you have amplified dot here. And the other technologies are related to witness or the wireless transmission, authentication, vulnerability, lack of encryption, or flaw in the flaws here in the software design. You have the other type of attack and vulnerability includes the following. The first one is the on-path attack. It relies on intercept transmission and they can take several forms. They call it the man in the middle here, right? So the man in the middle, it is you can see it. It's the most common one if you remember about the process of broadcast message. The process of broadcast message, right? Think about you learn about something about ARP, right? You learn something about DHCP here. What is the ARP? What do you think? What's the ARP here?
Address resolution.
Yeah, address resolution protocol. Right? So when you want the ARP, when you use the ARP, any idea? When you use the ARP here?
When you're like entering an address, I mean, not an address, like searching something and because you don't know the number series, so you're trying to access one of those servers to get the correct IP address associated with the name of the website. Sorry, I explained it very poorly.
No, it's not correct. It's not that way. So if you work with ARP, you remember the process of encapsulation and encapsulation, right? So see, before you send it to the destination here, you have the whole process. You have, you have the data here. You come from application. Now, when you come to the internet layer, you have to put the IP address, IP address here. And again, when you send it down to data link layer, you have the MAC address here. You have the MAC address here, and that here. So remember, whenever you send from the source to destination, you need both of the IP address and the MAC address here. And the ARP is used in the case that you know the IP address of destination, but you don't know the MAC address. You don't know the MAC address. So in that case, you use the ARP. ARP is a broadcast message. It's a broadcast message. It's sent out to everyone. That's the broadcast here. So you see, when you send it out to the street, and send it to the street here, and send it out to everyone. Send it out to everyone here. Now, it is a bad guy. It's a bad guy, right? So you see, when you send the ARP here, you raise a question here. Who is 192.168.1.10, right? And now he's not the 192.168.1.10, but he tells you that I am 192.168.1.10, and my MAC address here is a C, right? So instead of sending to the correct guy, now you put the number C here, and he just blindly send it to the bad guy here. And again, this bad guy here, he forward it to the correct one here. So you see, actually, the data transmission from the source to the destination here, you go to the bad guy here. Man is the middle here, and it transparently to the both of the source and destination. You have no idea. Actually, you have the man is the middle between the communication here. Right? It makes sense?
Yeah.
Okay. And DCP also. DCP is a broadcast message. So normally it's a broadcast message. That means you send it out and you raise the question, who is the DHCP server? But it's some bad guy, he pretends that he DHCP server here. So that is the case of the man in the middle. You have the de-authentication attack. You remember that whenever you want to access the wallet here, whenever you have to want to access network, you have the process of authentication, right? You have to verify what is the username and password here. And if you want to terminate it, you have something about the authentication here. So if you want to terminate it, you have to send the authentication message to the access point, and access point is the one who terminated it. But somehow, if you have the attacker here, he send the fake de-authentication. Send the fake de-authentication, so he can terminate your connection to the wallet access here. And you can have the insecure protocols of it. Some of the some of the inherently insecure. Like think about if you want to remote access to the router or server, you can use a telnet, right? Or you can use the SSH here. But the telnet, in the case of the telnet, everything is a plain text. Plain text, that means whenever you enter what is the username and what is the password here. And you can see if you capture it by Wireshark, you can see what is the username here and what is the password here. It's not secure at all. Right? But in the case of SSH here, everything is encryption. So even that someone he able to capture transaction, right? You capture with the Wireshark here. But when you look on the username and password, you have no idea what is it because everything is encrypted here. You have DNS poisoning also. DNS is a domain name service or domain system. What is the purpose of DNS here? What is the purpose? What's the purpose of DNS?
Alphabetizes the IP address.
Yes, right. So think about this one here. If you want to access sendgate.com, right? You see, when you go to the web browser, you enter here, sendgate.com, right? Actually, in order to route to the SendGate web server, right? You have to understand, you have to know what is the IP address behind that. I think about this one, 170 here, .10 here. But you see, instead of remember since sendgate.com or 170.10.10.10, this way way better, right? This way way better here. So in that case, they work with DNS. DNS it's a database. It maintains about the matching between the web address and the real IP address here. So see, when you go to the web browser, you enter sendgate.com. Actually, the computer is routed to the DNS server here. And in the DNS server, you have the database, and you have the matching between the IP address and the World Wide Web address. So see, now we read to the DNS server, and you raise a question here. I want IP address of the sendgate.com, and DNS server answer you. If you want to go to sendgate.com, you go to the 170.10.10.10, and from now you can route it to the SendGate server here, right? And you have the backdoor. So backdoor is a security flaw that allow unauthorized user to get access to the system here. That is something about the flaw when the configuration. Think about user unintentionally leave the username and password open to someone. He can access it here. And you have the malware. Malware is the malicious software refer to any program designed to intrude upon or harm the system resource. It can be the virus, Trojan horse, worm, bots, or ransomware here. And it's a general item. I refer to many kinds of the malicious software. You can have the virus, you can have the Trojan horse, you can have the worm, or you can have the bot or ransomware here.
Hey, are you struggling to get into cybersecurity? Now, before you click off of this ad, I have some information that I want to share with you that could completely change your life.
Turned on your computer and received a message like this one that says your computer has been locked, then you're probably a victim of ransomware. Ransomware is a type of malware that locks or appears to lock your computer, and they request that you send them money in order to unlock your system. The attackers are presenting a screen like this one, which might include an official logo. It might allege that you've done something illegal, and all you need to do is send them some money, and they'll be able to make all of this disappear. Of course, none of this is true. This is not the Department of Justice or Federal Bureau of Investigation. They did not detect you doing anything illegal on your system. They're simply trying to put a barrier between you and your computer and asking for money to have them remove that barrier. In some cases, this particular locking of your system is not truly locking it. Instead, it's putting up this nuisance page, and they're providing you a way to remove the nuisance page. In some cases, you can remove this page yourself with a proper antivirus or anti-malware software. The attackers are realizing that people are becoming more aware of these fake ransomware messages, and they've taken their game up a notch, and they've created a new type of ransomware called crypto malware. This is a type of malware that does encrypt all of your files on your system, and the only way to receive the decryption key is to provide some type of payment to the attackers. This is obviously a much more significant problem because you can't simply remove the malware and gain access to your files. All of your files and documents and pictures and movies have been encrypted. The operating system, of course, is still running, which allows you to see these messages appear on your screen, but all of your personal data has now been encrypted by the bad guys. This encryption is incredibly powerful. You're not able to brute force or guess what that decryption key might be. The only way to receive that decryption key is to send the bad guys some money and hope that they send you back the decryption key. One of the best ways to avoid any of this from occurring on your system is not only to run very good anti-malware software, but to make sure that you always have an offline version of your backup available. That way, if someone does encrypt all of your files, you can simply copy over your saved files from your backup, and you can continue operating normally without having to pay the bad guy any additional ransom. One of the ways that malware and ransomware can get onto your system is by tricking you to run that software yourself. This is something called a Trojan horse. The name comes from the Greeks that created a large wooden horse, hid inside of it, and then had that horse pushed inside the city of Troy. Just as the wooden horse was pretending to be a gift to the Trojans, Trojan horse software is software that pretends to be something else as well. It may tout itself as a Microsoft Office download or a game that you'd like to install. Once you install that software, you may or may not see the application you were expecting to see, but you were certainly infected with malware. This is something that can easily circumvent your existing security because you, the end user, are the one running the software on your computer. Once the malware begins to run, if it's recognized by your anti-malware software, you can then stop that before it gets onto your system. But some Trojan horses will disable your antivirus and your anti-malware before they install, ensuring that they're going to embed themselves onto your system. And once the malware is installed, it may download other types of malware that would allow the bad guys access into your system from the outside. Some malware is simply put onto your system to watch what you're doing. This is spyware. Spyware may be trying to present you with advertising, or it may be waiting for you to log into your bank or present a credit card number and capture that personal information as well. It's not uncommon to use the Trojan horse method to be able to embed this spyware on a system. So you may be installing peer-to-peer software, you may be installing security software that appears to be real, but in fact is fake security software, and that ultimately installs this malware onto your computer. This malware is designed to watch your browsing habits, to see what websites you happen to visit, and in some cases even capture the keys that you're typing into your keyboard. So every time you put in a username and password, the spyware could be capturing that information and providing it to a third party.
What's it like to learn science on Brilliant? Brilliant gets you hands-on to help you learn by doing.
And indeed, keyloggers can be a significant security concern. We type so much information into our keyboards that capturing that information could provide a third party with personal details, bank information, or credit card information. This would also provide details about what websites you visit, information that you put into emails, and so much more. These keyloggers capture everything that you've typed into the keyboard, so the attackers are able to go through an entire day's worth of information to see not only what you may have typed into a website, but what emails you may have sent as well. Of course, any communication you make when you're purchasing things online or visiting a bank account is all done with encrypted protocols over the network. But keyloggers are grabbing this information at the keyboard before that encryption takes place. So even though your network may be very secure, the keylogger is able to see all of that information before it's sent across the network. There are also specialized keyloggers that capture more than just what you're typing into the keyboard. They may capture everything you send to the clipboard. They may be taking a screenshot of your system every minute. It also might gather instant messaging or search engine queries. These keyloggers can provide a lot of details back to the attackers, and they can use that information against you. Here's what's gathered with a keylogger. I have Notepad running in the background here, and I've typed in username and password information in the Notepad application. In this dark Comet keylogger, you can see the logs of what was typed into my keyboard. And in fact, it documented that in an untitled Notepad document at a particular time, I typed in username Professor Messer and password not a real password. It even recognized when I put a space and then a backspace and finished the password. This log file would then be automatically sent to a third party, and they'd be able to see everything you typed in while that keylogger was running. Another rather serious type of malware is a rootkit. The term rootkit comes from the term root in the Unix operating system, where the root user is the super user or the administrator of the system. Rootkits are different than other types of malware because they are modifying the kernel of the operating system itself. It's not running as an application in the operating system. It effectively is part of the operating system, which makes it extremely dangerous because now it has complete control of the operating system. Not only does it have this level of control, but because it's part of the OS, it also is relatively invisible to the rest of the system. So if you were to open Task Manager in Windows, you would not see a separate executable or a separate piece of malware running as a separate task because it's part of the operating system itself. This also means that the rootkit becomes invisible to antivirus and anti-malware software, so it becomes incredibly difficult to identify that a rootkit is even running. Fortunately, rootkits are relatively rare, but if one is identified, the industry acts very quickly to produce security patches that remove that rootkit from the operating system. A virus is a generic term for malware that spreads with user intervention. You run an executable on your system, the virus is embedded inside of that executable, and it now begins running on your system. For that virus to now move to other systems, you would need to execute that virus on those separate systems as well. This can also reproduce itself through file systems or the network. Since many times we're running executables across the network, it's very common to have viruses use that network to be able to move from system to system. A single executable can be put on a shared file, and different people running that executable would then infect their own systems. Some viruses run behind the scenes like spyware, and other viruses are designed to attack your system, delete files, and create problems for the operating system. This is why running antivirus software on your computer is a best practice. There are thousands of new viruses created every week, so you have to make sure that you have the latest signatures for your antivirus software to make sure that your system remains safe.
So remember, you have to always keep it updated.
A virus that embeds itself as part of an executable is a program virus. It simply piggybacks itself onto the executable, and when the executable is run, the virus is also run. Another type of virus is one that can exist in the boot sector of an operating system, so you don't have to manually run an executable. All you have to do is simply start your operating system, and the virus will also execute. Some viruses take advantage of scripting, such as JavaScript, and can infect your system by coming in through your browser. And macros in a third-party application, such as those found in Microsoft Office, can be used as viruses as well that can delete data or send your files to a third party. Most viruses need some type of human intervention to get the virus started and running on a particular computer. But there are some types of viruses that need no human intervention at all. These viruses are categorized as worms. Worms are able to self-replicate themselves between system to system without needing any human to interact with those computers. This can obviously be a significant problem because worms are able to use our high-speed networks to propagate very quickly between systems. These worms are so fast and so prevalent that you could plug in an unpatched system that is accessible from the internet, and that system would be infected in a matter of minutes. Fortunately, worms are relatively uncommon, and usually we can create signatures to look for these worms coming through the network that we can then embed into an IPS to prevent that traffic from coming to the inside of your network. Of course, once the worm is inside the network, it's also free to move from system to system, so you have to make sure that you keep all of your anti-malware updated with the latest signatures. An example of a worm that installs ransomware on systems is the WannaCry worm. WannaCry starts on a system that is already infected, and that system begins looking across the internet to see what other devices may be available. If it finds a system that is susceptible to a particular vulnerability, it can then be exploited. WannaCry uses a type of exploit called Eternal Blue to be able to gain access to these systems. Once Eternal Blue is installed onto these systems, it downloads the malware and installs WannaCry onto that operating system. And then the process simply repeats itself. That computer now looks for other devices and it begins installing the software on those. And the process repeats again. This process will continue to repeat itself until you patch the operating systems or block this traffic on the network. Sometimes the malware that gets installed onto your system is not trying to delete your files or encrypt any of your data. Instead, it wants to turn your system into a robot. This is a type of malware called a botnet. And an interesting part about this botnet software is that you may have no idea that your system is infected or that it's performing any of these automated functions as part of this larger botnet. Botnets can be installed with worms, with other viruses, with a Trojan horse, or any other method that it can use to execute that malware on your computer. Once the botnet malware is installed on your system, it usually sits and waits for instructions from some other third party. A third party will then communicate to the botnet and tell it to participate in a denial of service, send out a series of emails, or anything else that the third party wants your system to do using that botnet software. If you want to see botnet communication in real time across the internet,
so we have definition, right? We have the malware characters description, some malware encrypted to prevent the detection. Still, it's all of the information. What do you think? What is the following social engineering attack? Require attacker to have exacting knowledge about the victim. What do you think about this one?
Phishing?
Yeah, phishing, right? The phishing that it always has some of the information about existing knowledge here. So we know what is your, where you work, or that has that come to you, right? So we have to take advantage of it. You already know some of your knowledge. Okay, so basically we know that we have some of the range, right? Some of them, half of them is the most commonly come from the human. That's why the first action here always you have to take action to train the employee to know how to detect the suspect action, right? And you have some of the risks from the technology. It can be the it can be DOS attack, or it can be about the worm or virus. So now we have the risk assessment and management here. Effective risk management happens at the two layers. The first one is the security risk assessment here. You have to evaluate the threat and the vulnerability of the network. The second one is the business risk assessment. You have to evaluate the impact of potential threat on the business process. And the business process is a series of steps that you can accomplish to define the goal. And you have preventer risk assessment, the third-party risk assessment here. That evaluates the security and compliance risk related to supplies and the vendor the company doesn't easily do it. You have a voucher agreement, and you have the security auditing. The assessment performed by a company. Normally, you have the hire a company that can be accredited by an agency and set the network security standard. Okay, and you have the attack simulation. Right? Sometimes you have to simulate it in order to see how can you react to the attack here. right? So in the case that if you have the real attack, how can you react to the attack here? So during the posture assessment, you might use some of the method a hacker used to identify the cracks in the security architecture here. The first one, the vulnerability assessment, is used to identify what is your weakness, what is the vulnerability in the network here. You have the two types of assessment, can be authenticated. That means you attacker already given some access of the chat to the network here. So you can think about you can get him. Sorry, you can give him some of the information about the network, right? What is the IP address? What is the port number? And give you some of the information and see how you react in the case of the attack here. The second one is unauthenticated. That thing about totally the stranger here, right? The attacker from outside here. So how he behaves and how you attack it in the network here. And you can have the penetration testing. You use a variable tool to find the network vulnerability and attempt to exploit them. And you can have the breakdown in the red team and blue team. You have the red team is the one who attack, and blue team is how we react, how we protect the network here.
At Kroger, we believe in holding fresh to a higher standard. Kroger, fresh for everyone.
Unlike a penetration test, a vulnerability scan usually is not very invasive. It's simply gathering information about what can be found without actually performing any exploits on a system. We might.
You see that Nmap here already did it on the homework, right? That is a tool here to scan the network here to know which IP address available, right? The first thing is which IP address here available, and for each of the specific address available, you can tell which port here you are open here, right? So see, when you have information about the IP address and we have information about the port open here, you can take action to exploit and do some attack to the network.
Perform a port scan to see what services might be open on a particular server and find out what version of those services may be running. All of this can be done without logging in or performing any type of exploit on those systems. You can perform vulnerability scans from outside the network, but you can also perform your own vulnerability scans from inside the network. It's usually a good idea to do both so that if somebody did gain access to the inside, you'd know exactly what they would see. A vulnerability scan will gather a large amount of information. Some of the details in the vulnerability scan will be informational and low priority, and others may be high priority and critical. You want to gather as much as possible, and then you can sort it out after the vulnerability scan is complete. The vulnerability scanners that we use these days are very powerful. They use a lot of different techniques to try to find out information about a server or an application. One method of scanning is a non-intrusive scan, where we're simply gathering information about what we're seeing on the network. This might be simply a packet capture process and then looking through those packets to determine what conversation might be going on. The scan may be a little more intrusive, where we're checking a vulnerability to see if it exists without actually taking advantage of that vulnerability. This might also be a non-credentialed scan, where you don't have any access to that server, you don't have a username and password that you could use to authenticate. The scanner is going to act just like everyone else who's sitting on the outside and trying to get into that system without any specific credentials. Some scanners will act as a credentialed attacker. So you provide the scanner with a legitimate username and password. It uses that to get into the system as a normal user and then tries to find ways to get around the existing security. I'm running a vulnerability scanner on my system called NETI. It's designed to scan web servers and find out information about what.
Okay, so I think it's need to know about the definition. So basically, you see, they can scan the network, right? See what is the IP address available, what the port available here, and you get information, and you can use it for the later attack to the network here. And you have the penetration setting. You can use a lot of tools to find the network. Let's see what is this.
Switching to Allstate is easy, and saving is even easier. Click for a low auto rate today.
If you're performing a penetration test, then you are actively trying to gain access to a system. This is simulating the same type of exploits and attacks that would be done by an attacker that is external to your organization. This is similar to the process you go through with vulnerability scanning, but you're taking it one step further. You're actually trying to exploit the vulnerabilities you find to see if you can gain access to these systems. This is often a process that is mandated. You have to do this by some type of set of rules or regulations, and you'll usually contract with a third party that will perform these penetration tests on a regular schedule. A great document to view some of the information that can help you design and plan for these penetration tests is from NIST. It is their technical guide to information security testing and assessment, and you can find that at professormesser.link/800115. Penetration tests can be very invasive, and it's important that everybody understands exactly what the rules are for these particular tests. These rules of engagement define the purpose of the test and what the scope will be for the people who are performing this test on the network. This means that everybody will be aware of what systems will be considered and perhaps the time of day that will be used to perform these tests. Most organizations will define a type of test. So this may be a test of a third party coming in from the outside, or it might be a test that you're performing internally to your network. And you also have to make sure that everybody understands this is something that might be occurring during the normal working hours, or it might be something done after everyone's gone home.
So basically that is about the definition information only. So I don't want to go into detail. And anyway, I have the slide. I think I uploaded on the slide, and if you need one slide, I can upload it, or I will upload it. This one, right? Yes, so we have the slide here. So if you want to have the deep information about that, you can find the slide and you can watch video later. But anyway, for this class, again, it's only about the definition, so I don't want to go into detail much about that. And you can simulate attack simulation. You can break it down into red team and blue team. Red team is the one who attack it, and who defend its security. And the scanning tool, you get it on the assignment already. You would use the Nmap here, so we can see what is availability, what is available host, what IP address available here, and you can see on the port number. From the port number, you can see information about the application here. That is a scanning tool. You can use the Nmap, Nessus, or Meta Spot. And the honeypot and honeynet. Honeypot is you do it intentionally, right? You see, when you design the network, you have the honeypot. Is that from the outside? When you look into the network, he can think that it's very easy to take the action to exploit the weakness of the network here. But actually, it is you keep it intentionally to draw the attention from the attacker instead of doing to harm to other network. This one.
Digital security, everywhere you need it.
A honeypot is a security tool that allows you to attract hackers and people trying to use their scripts and vulnerabilities on your network using the sweet smell of honey, or at least a digital version of it. It's a system that appears to be open, or at least to have the door cracked just a little bit to entice the bad guys to come in and try to hack around and understand what's going on. But of course, it's a controlled environment that you get to see and you get to watch what the bad guys are doing. It's a great way to gather information on the types of techniques they're using to get into your network. It also allows you to prevent them from going anywhere else in your organization. These days, there's no human being that's manually sitting at a keyboard and trying different techniques to try to get through your firewall or try to get to your email server. It's almost always an automated process. It's a series of scripts. It's a series of applications and programs that are methodically going through hundreds or maybe even thousands of different techniques to try to get into your servers. And if you have a honeypot set up, you can see exactly what they're trying. You can see the techniques they go through and understand exactly what they're stepping through to try to break into your systems. You can have honeypots that are set up as single-use traps. They are there just for the moment. You've built them out for a very specific purpose. You can also set up a honey net, which is an entire series of honeypots that may be on one network or maybe extending between different networks that allows you to begin consolidating information together. You can start to see patterns and understand if the traffic coming in is coming from one type of person or maybe multiple sources based on the traffic patterns that you happen to see.
See that is a trap, right? From the attack point of view, it looks it's very easy to break into the system, into the security here, but actually the trap you intentionally to draw the attention from the bad guy. What else? Okay, now you have a lot of security, but one thing is that whenever you work in security, you have to think about, you have to work with the layer, right? You have to work with the layer and you have to do with the diversify the layer here. I think about you are not only one layer of the security, but you can have many layers of the security, and you also have to diversify the layer. Right? So one layer, it can be the physical layer. You can have you have to scan. You have the finger detection, and you have to diversify in the layer here. And so for the physical security, it is whenever you want to access into the critical component, it must be restricted and the control here. You can use a locker, you can use a lock door, or you can use a camera or motion detection here. You have a lot of things to do with the physical security here. Okay, so here's a sum of the prevention method you can access, you can apply it to the security network here. You can use the keypad or the cyber lock. You have access badge. You have biometric, right? You can have access control. You have the locking guys, have the locking camera, and have the smart locker here. And also have the detection method. You can use a motion detection. You can use a camera. You can use a tamper detection, or you can use a set tag here. And you can have the device hardening. It's a good step to secure a device from the network or the software supported attacks. And you have many layers of defense you can implement it. Think about it. Whenever we work with the security, you have to implement in layer, not only one layer. Right? You have to implement a layer. And each layer, you have a different method in order to implement for the security here. And that thing is very simple, but you have to pay attention for this, right? So if you have you only have to update and security patch here. Right? Update to the application, your operating system, you have device a firmware, fix bugs, and add new feature, and close any security gap here. Okay, so it's a process probably managing applying security patch include discover, standardization, and in-depth vulnerability reporting, implementation, assessment, and the risk mitigation. And user administrative credential. Many devices are managed through the remote access. So instead of using the plain text access like the telnet, you can use the NFH here because NFH you can use the encryption here and it's more secure. And you have some you have many device offers option for configure several administrative account with very level access. Some user account are given privilege access and security precaution can cause a taken on this account, including the limited use, limited location, limited duration, limited access, and limited privacy. Right? So you see that you can limit it on use, right? So for example, I give you the example here. If you are the front office engineer, you only have the limited to some of the limited show command here, or you can limit it on location, right? So you only able to access to the router or switch when you go to the data center, right? Or you can use a limited duration. Say, think about you work on the shift and your shift is only from the 8 a.m. to the 2 p.m. and you only give the access into the device during short duration only. And limited access also, you have to access into the some of the limited resources and you have a limited privacy. And you have the some of the services and the protocol. Insecure service or protocol should be disabled in system whenever possible. So think about you have the both of the telnet and at edge, you should disable the telnet in order to prevent about the security here. Right? And you can protect device following this guideline, reduce access path, choose a secure protocol, reduce startup process, disable unneeded service. And you have the close unused port here. And the password management is the hashing. The hashing is meant to transform data from an algorithm to reduce the amount of space need for the data. Now we have the SHA here. Secure hash algorithm is the most common use in the hashing algorithm here. And its primary advantage is it's resistant to the collision here. And you can have some of the version of SHA. You have the version 1, sorry, 0, 1, 2, and 3. Right now is version 2 and 3 are the most common one in order to enhance the security here. Okay, so with the password, so we learn about the private, you have the public password key, right? And you have the private key, you learned it already, so I don't want to go with here anymore. And you have the anti-malware software. Malware generally leave the evidence of itself. Some malware can detect only by the anti-malware software. And you can have some of the symptoms of the malware here. The first one is unexplained increase by the file size. You can see the abnormal increase in the size and significant unexplained system performance decline. Slow down the process here. Use unusual error message, significant unexpected system memory loss, and periodic and unexpected rebooting and fluctuation in the display quality here. And in order to keep it with the malware, you always have to keep it updated. Right? You have to keep it updated here, and you have to update for any patch you have to. Okay, so when implementing the anti-malware software, one of the most important decisions is to install the software. And some of zero includes the host base, the server base, network base, or cloud base. And you have to decide where you want to implement the security here. And you have the asset disposal, right? In the case you want to get rid of the information, you have to follow the process here, right? So if the mining data from this customer device and to company operation, property system, and sensitive data, your company is legally responsible for the data contained on the device, even after you stop using them. Some of them you have to comply with the regulation here. And you have for every company, you only have the security policy here. Specify what is step you have to follow in order to protect the network here. So we think about, you have specified that you have to, every employee must have to go through the training process, right? How he will react to the phishing email, how he will react to the phishing call, or how he will react and how often you have to change the password, and you cannot reuse the password, and what is the minimum length of password. Everything is that it is in the security policy here. It specifies the document, and you have to follow it when you work with the network here. Okay, so security policy goal, you have the sum of the goal for security policy, including the ensure the authorized user and have the appropriate resource access, prevent the unauthorized user access, and protect sensitive data. Everything here is information that you can look on the slide. I don't want to explain it in the detail here. It's everything about the definition only for this one. Okay, so nowadays one of the most challenging is bring your own device. You see, you can bring all your own laptop, cell phone, and you can access to the network here. Right? So that's why you also have to you also have to develop the way how to protect it and your network from the cell phone, from the iPad. You bring to the company here. And you have acceptable user policy. It explains user what they can and cannot do. So normally it normally do in the process when you just got hired from the company, right? So when it just got hired, you have to understand the policy of the company here, how you have to follow with the security policy here. And you have non-disclosure agreement. Also, you have to comply with the regulation for any non-disclosure agreement. You have to follow with here. Think about information about the health data, right? You cannot disclose it here. And you have the password policy. How often you have to change it. How long it is, right? You have to specify that minimum of the password length is a 10 character, and you have the combination of the both of the number and the character and special character. That everything is about password policy here. Okay. That is a privileged user agreement. Right? That already I mentioned is that it already give you the privilege. You need to do the job, but never ever give you more than that. And have the anti-malware policy. That is a policy here. You have every computer equipped with the malware detection and cleaning software, and you have to often update and then upgrade it here. Okay, so this module everything about the security. So it already and it's everything about the definition only. You don't have too much thing to do with that. So I strongly recommend you to read again about in the Cengate book or in the slide here. So let me see what you have for the whole book. Any questions so far?
I have a quick question. When do you think you're gonna have the class recording up so I can rewatch the beginning, just in case?
Why you ask question up to now? We see. Let me